Good afternoon, everyone. I'm delighted to greet you to our very first presentation for our community in our Fine Arts Theater. And I'm so thankful that so many of you showed up today for a very exciting talk. Students, faculty, staff, alumni, parents, Board of Trustees, thank you for your support of JIS, for being here at this event.
Thank you for the wonderful introduction. Thank you, folks, for coming here this afternoon. I'm really excited to be sharing this room with you and tell you a little bit about artificial intelligence and my research on this topic. It's actually pretty interesting challenge to talk about AI, as those presentations just get obsolete, weeks after you design them. The progress is so fast that it's difficult to keep up, even for me, where I spend essentially most of my time just trying to follow up and keep up. All right, so we'll be talking about making sense of modern AI. But let me first take you to 1996, the times of good old AI. This is the year when Garry Kasparov, the reigning champion of chess, for the first time lost a game to a computer. IBM's Deep Blue, after around 10 years of development and planning, running on a huge computer, was able to win one of the games. But it also lost the remaining games, so it lost the tournament. Now, next year, in 1997, IBM came back with a greatly improved and much more powerful machine. And this time, it won 3 out of 5 games, winning with Kasparov and marking a turning point in the competition between human and the machine. For many years, people thought that it's just not going to be ever possible that a computer could ever win with a human chess expert. And actually, look at this plot here showing you the progress both of human skill in chess and artificial intelligence skill in chess. You can see that just 10 years before, artificial intelligence was at the level of a strong club player at 2,000 ELO points. Now, from a perspective of Kasparov, it wasn't even worth playing with such a computer. The chances of this computer winning were below 1%. And yet, 10 years later, it was able to win with the strongest player out there. Now, let's take a look at this machine that for the first time won with the reigning champion, IBM Deep Blue. You can see it's quite a huge computer out there, and there's additional machines that were helping it. It could predict 200 million chess positions every second. Now, if you think for a minute, for example, about the next move, it's quite a few positions that you can consider going forward. Moreover, Deep Blue had a huge database. This database included all of the games ever played by chess masters. So oftentimes, it didn't even have to think much about what to do next, because it just remembered perfectly well what a grandmaster did in the same situations 50 years earlier, and could leverage this knowledge to outcompete Kasparov. That, of course, Kasparov also studied the games played by grandmaster. He was a grandmaster himself, but surely it was not possible for him to remember move by move every single game played by by grandmaster before. Moreover, Deep Blue had a database of all possible 5-figure endings of the game. Again, it didn't need to predict any moves. The moment you reach the stage of the game where there's just five figures left, all of the future games were just stored in a database. You could just look which of those endings, which of the strategies was a winning one, and just play it, essentially just looking at its notes. And also it had many 6-piece endgames. Okay, so this powerful computer being able to consider 200 million positions per second and having this huge database of archive games beat the reigning world champion. But now a question to you is it that Deep Blue really understood chess? Did it really know how to play chess? Now, philosophers of mind were thinking about this question for quite some time. In 1980s, or 1980 actually, John Searle proposed a famous Chinese room argument. He imagined a room where he's sitting. He doesn't speak a word of Chinese. He's a native English speaker. But on one side, there's a little display. So you can approach the room and type some Chinese characters that will be displayed inside the room. Now, John doesn't speak Chinese, but he has a lot of rule books that allow him to check the inputs and translate it into some output and then draw it on a piece of paper and then just drop it into this output pipe that would just present it to the person that is waiting outside. And John Searle said, look, from the outside, it seems like this room speaks Chinese. It seems that it understands Chinese. It seems that it thinks, there's thinking. It can respond to my queries. And yet, Searle argued, if you look inside, you see that it's just me following instructions. I have no idea how to speak Chinese. I do not understand Chinese. So he argued that this thought experiment proves that machines like IBM's Deep Blue do not really think, do not really understand how to play chess. Now, other philosophers disagreed with Searle. People argue, well, maybe person inside doesn't understand Chinese. Maybe the room doesn't understand Chinese, but the system of a room and a person potentially understands Chinese. Others, like Turing, well, it was way before, in the 50s, Turing came up with a similar problem, and he said, look, it actually doesn't really make sense to even worry about this, because if from the outside it looks like the machine is thinking, let's just assume that it's thinking. It's just the most efficient thing to do. Now, we will not solve this debate here today. It's still ongoing. You can disagree with me. I personally think there's no understanding in Deep Blue how to play chess. There's no knowing. There's no thinking. It's just simple following rules. And yet, you can still beat Kasparov without thinking. And now Kasparov agreed with Searle. As you can see here, despite losing to Deep Blue, his comment afterwards was like, look, it's as intelligent as your alarm clock. Once again, despite having lost to Deep Blue. Now, IBM, after the game was over, the tournament was over, IBM dismantled Deep Blue and refused rematches. Kasparov wanted to play again. So for quite some time, nothing really happened. But then you could see some more progress where machines had even larger processors and even larger memory. Essentially, they became even better. But let me take you now to 2017, when a very interesting thing happened. Namely, researchers at DeepMind, now a part of Google, they set up a very simple algorithm that was supposed to mimic how the human brain works in a very simplistic way. This, by the way, wasn't new. We knew about artificial neural networks for quite some time. It's just we never had enough computing power to use them effectively. So it's a bit larger than what you can see here on the screen. In reality, it had 80 layers and 10,000 neurons on each layer. So the network would be larger than what you can see here. But even such a network you could potentially display on this slide. I just didn't have patience to put 10,000 neurons per layer here preparing for this talk. So they took this artificial neural network and they did a very interesting thing that people didn't really think about doing before much, which is instead of explaining to this network how to play chess, instead of giving it any archive data about past chess games, they essentially put two neural networks like this in front of a chessboard and said, play. And on the surface, it's a kind of a silly idea, like, hey, those networks have no idea. They never seen a chessboard before. They would just play naively, like randomly, like a child that has never seen the game before. And that's what they did. For many first millions of moves, those networks were completely naive and random. And yet at some point, one of them just, well, even when you play randomly, one of the player wins and another one loses. Now, the network that won would be rewarded. How would you reward the network that won? How would you reward, how would you make it take a lesson? Well, network works in the following way. On this side, those neurons look at the chessboard and see what's happening on the chessboard. And then they pass the signal and process it in very simple ways. Let me not go through it here, but essentially what happens is that at the end, here, those neurons at the end of the network, they vote for the next move. And once again, those networks did not know how to play chess, so at the beginning, those votes were entirely random. But sometimes, even a random vote gives you a move better than your opponent could think of, especially if it's another very badly playing neural network. So then what you do, you reward those neurons that voted for the good move, and you give them more weight next time they play chess. And again, so we can do this over and over again. For first few millions of games, those networks are really, really bad. But then what happens? At some point, one of them starts getting it. And then the other one has to keep up to have any chance of winning. And then it motivates the first network to try even harder, to come up even with better moves. And again, this coming up is random, but sometimes it does it, and then it gets rewarded. And if you repeat this process over and over again, you arrive at the model that plays pretty well. And when you think about this is not unlike we teach kids how to play chess. You can explain as much as you want the rules of the game and the strategies that are winning. You can have your kid to read all of the textbooks and so on and look at the games of masters. But ultimately, to learn how to play chess, to really understand how to play chess, you need to play it. So after 4 hours of playing with itself, AlphaZero became the best chess player ever. By the time, of course, humans were far away from being good chess players, it just became best of the chess programs playing chess. It was described by grandmasters as insane attacking chess or superior alien species when playing chess. So let us look now at how it is possible that it essentially became a much better chess player than IBM Deep Blue. Look, this network also could predict some future moves. It could predict on average 70,000 positions per second, future position per second. So like us, when we play chess, we also try to think ahead, maybe 1, maybe 2 moves ahead. It also could think some moves ahead. But compared with 200 million positions used by Deep Blue, also this network got no database of games played by grandmasters. It never learned from any human. It had to discover all of this on its own. And yet, without any instruction, any textbooks, without much ability to plan ahead, it became 10 times better. We can see it here on the plot. Look, AlphaZero versus Deep Blue. This difference on ELO scale means that it was 10 times better than not only grandmasters of today, but also than IBM Deep Blue. And actually, this plot is not really showing you the magnitude of progress, because ELO scale is really exponential. It should be more stretched. If you represent it as chances of winning a game, you can see that the progress of machines is much steeper than whatever you can observe for humans. OK, so let us now return to the question that we asked about Deep Blue. Does AlphaZero know how to play chess? On the surface, it's also a machine. But there are some differences. Look, IBM Blue was simply looking into a database to figure out what is the best move that it should make. This database was created by grandmasters when they were playing their games. Also, Deep Blue was kind of hacking chess. Instead of thinking what would be the best next move, it was stupidly calculating 200 million next moves per second and then trying to pick one that is best. Now, AlphaZero was very different. It was never shown an instruction manual how to be good at chess. It was looking forward a little bit, but not much, and yet it was 10 times better than Deep Blue. Now, when you look closer at this neural network, when you zoom in, look at a single neuron. When you look at the single neuron, it is the same as the Searle's Chinese room. It gets some input, then what's happening inside the neuron is it just tries to process the information, figure out what to do with this information, and passes it on. A single neuron doesn't know how to play chess. A single neuron doesn't even know that it's playing chess. It just gets signal from other neurons and then follows its instructions to process it and pass it further. But the magic that happens when you put together tens or hundreds of thousands of neurons in this intricate structure of a neural network is that it can behave in very unexpected ways. Suddenly, a network composed of neurons that individually cannot play chess, they don't even know they're playing chess, suddenly can cope with unexpected situations, can learn from experience by playing with itself, can become better with practice until it becomes better than any human that ever played chess and better than any program like IBM Blue that is playing chess. Now, when you look at this description of artificial neural network, where each of the neurons is this kind of mindless, thoughtless machine that just processes input and translates it into output, does it remind you of anything? Well, it is not unlike a human brain, where each individual neuron in a human brain is just a relatively simple biological robot. Has 7,000 synapses, reads the input, then processes it, decides whether to pass the activation or not, and then that's it. There's no consciousness in a neuron. There's no knowledge. There's no thinking. There's no understanding. It's a simple biological robot. And yet, if you add 85 billion neurons that you folks carry in your head, suddenly all of those properties, consciousness, thinking, understanding, feelings, ability to play chess, emerge as an emergent property of the network of those mindless neurons. So again, we probably will not solve this debate today, and many of the philosophers of mind would disagree with me, but my intuition and my claim would be that neural networks, AI employing neural networks, behaves in ways much more similar to a human brain and should be interpreted, should be credited with similar abilities. Now, I'm not saying that AlphaZero was conscious or her feelings. Look, the size of this brain, of the AlphaZero's brain, is really tiny. I tried to plot it to scale. It's only 800,000 neurons. It's essentially the size of the brain of the honeybee. So I'm not saying it has consciousness or feelings or that it can use language like we can. But it clearly can play chess better than Kasparov and then better than any other Chinese room-like machine. It can learn. It can adapt to new situations. It becomes better with experience, as shown on this plot here. So the claim that I'm trying to make here today is that while this good old AI was really accurate at calculating things, it had a lot of logic but no intuition, it had well-defined applications, its performance was driven by the underlying computing power. It could beat Kasparov by just out-predicting the future, mindlessly and stupidly predicting all of the future potential situations on a chessboard. This new modern AI, based on brain-like structures, has intuitions, can adapt to new situations. Its performance doesn't depend as much on the CPU on which it's running on, but rather on the experience that it had, right? You can run this neural network or on as fast computer as you want, and it's going to be absolutely stupid unless you let it practice by playing chess a little bit, very much like a human being. So my first take-home point for you folks, in trying to navigate this AI revolution that is affecting our lives, and if you think it's not affecting yours, you are wrong or live in a cave, that a good metaphor when we think about what AI can do, what it can't do, how to interact with AI, what are the dangers of AI, what are the potential benefits of AI, in order to answer all of these questions that I don't think we actually have very good answers for us today, is to think of AI as if it was a brain. Not exactly the same brain as a human one, but a brain, rather than just a simple deep blue-like calculator. Okay. So let me fast forward to 2018. What happened there? In 2018, researchers, this time at Google, set up a model called BERT. It was very similar, actually, to the neural network used in AlphaZero, but this time, instead of playing chess, this model was supposed to predict a next word in a sentence. So what they would do, they would take a paragraph from a book, or paragraph from Wikipedia, or paragraph from a website, remove one word from this paragraph, and then ask a neural network to predict what this word should be. Now, very much like with chess-playing networks, for the first few million tries, those neurons were coming up with the stupidest ideas. You may have written a sentence, "Today I would like to eat a," and the model would say refrigerator. Makes absolutely no sense. But then you essentially say, okay, that's not a good vote. Try again. And at some point, it will actually say something that makes sense in the context of this sentence, and then you reward those neurons. You say, good neurons, we want more votes from you next time. And after, in context of BERT or Albert or GPT-1, they were all models that were created back in 2018, it would take about a week of training, a week of those models reading millions and millions of pages of text. And after some time, they got quite, well, quite maybe is not a good word. They got somewhat competent in using language. Now, it doesn't sound really impressive now, competent in using language in the era of GPT-4, but trying to design machines that were any good at language was a huge challenge for computer scientists for ages. Guys, playing chess is a trivial pursuit compared with being able to create competent sentences, something that all of us do fairly easy. Okay, so let us look at those models designed in 2018 and consider their size. They were very similar to AlphaZero, just smaller. So for example, AlphaZero, again, size of the brain of the honeybee. When you look at one of the first models of this era, GPT-1, only 110,000 neurons. It was a toy. It was a proof of concept. Again, I tried to, not sure if you folks see, I tried to plot the size of the brain to scale, comparing it with AlphaZero and with our brain. It's roughly the size of the brain of a spider. Okay, so let's see how this spider brain, I forgot to mention, isn't it striking that a honeybee brain can win with Kasparov and then be 10 times better than Kasparov as well? It's pretty amazing. Okay, let us try to see how GPT-1 uses language. My name is Julian, and I like to drink your drink. Do you know how old you were when you first met me, Julian? Oh, you are young, young, and young again, said Julian. Now, that's pretty bad, huh? But also, the model clearly figured out punctuation. The order of words roughly makes sense. There's some structure to this sentence. It figured out a dialogue. It can use a question mark. Have you noticed it doesn't know about capital letters? For simplicity, all of the letters were decapitalized, so the model doesn't have to struggle with it, right? But you know, it crafted some sentences. Let's just try to give it something more difficult, okay? All right, so that was my query here. The following is a humorous limerick describing a typical day of a new parent. I'm a new parent, so I wanted to have a little poem written for myself. Do you guys know what the limerick is? Well, let's ask one of the models. What is a limerick? Be very concise. A limerick is a humorous 5-line poem with an AABBA rhyme scheme. Example? Here you go. There once was a man from Peru who dreamt he was eating his shoe. He woke with a fright in the middle of the night to find that his dream had come true. That's a very popular poem in some places. I quite like it. All right, so let's see how good GPT can be, GPT-1, at writing poems. A day of the week, a day of the week, a day of the week. Not very good. Okay. Next year, 2019, they were very encouraged by GPT-1, so now they created GPT-2, which instead of 110 neurons had 4 times more neurons, 400,000 neurons. The following is a humorous limerick. Okay, let's see what it says. I'm a little boy and I'm a little girl, I'm a little boy and I'm a little girl, and so on. Again, those are valid sentences. It's just completely ignoring what I wanted from it or just failed to understand. All right, next year, GPT-3, Curie, version 900,000 neurons. A new parent's day is a day of laundry, dishes, and diapers. It's a day of exhaustion, but it's also a day of joy and happiness. Now, all right, it kind of makes way more sense than before. Definitely not a limerick, but it kind of is a poem, right? So maybe it didn't know exactly what the limerick is. Maybe it couldn't do the rhymes, but it kind of, just went in this direction. Okay, let's see. There's clear progress. Let's see, 2022, GPT-3 Da Vinci with 175, 4 million neurons. 4 million neurons. There once was a new parent so tired, their baby was up all night desired. They tried to get sleep, but the baby would weep, so the parent was left quite expired. Guys, we have a limerick. Not a very good one, but definitely a limerick. All right, let's fast forward to today, 2023. We have ChatGPT-4, 10 million neurons. So again, 2 times more than GPT-3. And let's see whether it can write the limerick for us. There once was a parent quite new whose sleep every night was quite few. With diapers and cries and sleep-deprived eyes, they wished babies come with a how-to. I'm not good at reading it, but you can see it's a much better limerick, okay? But also at some point, I won't be able to tell the difference between good limerick and a very, very good limerick and a genius limerick. I'm not an expert in poetry. They're all good, kind of good for me at this level. But hey, let's make it a bit more difficult for the model. Cool, translate it to French, but keep the rhymes. Can someone please read it for me? Come here, Florian. You will read it for us. Let's see if it rhymes.
Il était une fois un parent novice, dormant peu, la nuit était un supplice, avec couches et pleurs et yeux sans ferveur, souhaitant un mode d'emploi pour ce service.
Thank you. Is it good? French-speaking part of the audience? Good, great, okay. Write it now in a pirate English. Keep the rhymes. There once was a parent, you see, who slept where as scarce as a tree, with diapers and wails and nighttime sea tales. They wish babes came with a sea decree. I have to practice this. All right. Okay, now write notes so I can sing it. Certainly, no problem. For the limerick in pirate English. And, that's way above my pay grade. But you can see that now it can just do so much more than it is a day, it is a day, it is a day. All right. And also, let's see how it compares to a human brain. So GPT-1, 110,000 neurons. GPT-4, 10 million. Again, this is to scale as much as a zebrafish. Guys, a zebrafish wrote a limerick, translated it to French, pirate English, and then told me how to sing it using notes. And let's not forget that this brain, zebra-sized brain of GPT-4, is missing many of the wonderful things that human brains have. It doesn't have neurotransmitters. It doesn't have myelin sheaths. It just doesn't have so many of the biological equipment that we have in our heads to make our brains even more efficient than what just simple neurons can grant us. But also, let's look at the size. There's nothing preventing us from training ever larger models. And we are getting better at this, and we're designing better chipsets. There's nothing preventing us from blowing up the size of the model that is already a better language user than certainly I am, to be maybe not the size of the zebrafish brain, but maybe a rat's brain. Or maybe make it a human brain. Or maybe make it an elephant brain. Or maybe make it an even larger brain. What stops us? And just to let it sink, already at the zebrafish size, it's a better language user than certainly than I am. All right, so the number 2 take-home point. We are far from the limit of what is possible in using neural networks to do stuff for us and think and understand things and win chess with us and craft language and code and so on. All right, so let us look at this progress here, because it's another interesting phenomenon. Who heard of language models this year? Hands up. Who has heard? Let me reset the question. Hands up if you have ever heard about large language models before this talk. Hands up. Come on, guys. More people must have heard of language models before this talk. You really learned about it today? OK. Who heard about them last year already? OK, we have a few hands up. Who heard about them 3 years ago already? Nearly no one. OK, 1, 2 hands. Who heard about it back in 2018 when we had GPT-1 trained? Well, I heard about it. I'm very proud of myself. But clearly very few other people out there. And folks, this is because people just don't really pay attention to things that are not that smart or not that good. Look, there's a language ability plot. An average human, let's say it's somewhere here. Look, there's no scale here. I just removed it because it's a hypothetical plot. But we have an average human here. And look what happened. For most of the last few years, large language models were complete idiots. A day is a day, a day is a day, a day is a day. What kind of limerick it is? So you don't even notice. You don't care. Who cares? What is it useful for? It's some kind of gimmick. OK, OK, OK. But we have 2023. Suddenly, it can write your essay. It can do your homework. It can solve your test. It can score on SAT better than most of us, OK? Suddenly, people are like, wow, there's something happening with this zebrafish out there, OK? It's really interesting. But now, let's not forget about the following thing. Each of those models, published year after year after year, had 2 times more neurons. Now, 2 times more neurons means, I forgot the exact number, but many more synapses. And what really matters is just not numbers of neurons, but it's synapses, connections between neurons. So 2 times numbers of neurons gives you whatever. Let's assume it's something around square times more synapses. It gives you a lot of synapses, meaning that this progress is exponential. The difference between GPT-3 and GPT-4 is as large as between GPT-3 and the earliest and the stupidest model that we have ever trained. And the distance between GPT-5 and GPT-4, GPT-5 is going to be so much better than GPT-4 as GPT-4 is better than nothing. We're doubling our progress essentially at the moment every single year. And it's not a new phenomenon. It happened before with CPUs, with computers. They were becoming better, 2 times better every 18 months. And the same phenomenon happened. At the beginning, it was just a gadget in the labs. Then everyone had a phone, and everyone was boasting what kind of CPU they have in the phone, because there was a real difference between your CPU and my CPU. Now, the progress still continues. It's just the CPU is so good that it satisfies all of our needs. So you don't even know what the CPU you have in your modern iPhone. But you know what you also don't know? That your iPhone 13 is still 2 times better than iPhone 12. And iPhone 15 will be, again, 2 times better than 14. The progress continues. But when you look at Garry Kasparov versus another grandmaster that is much worse, most of us can't tell the difference, because it's just so much above us that it's just, it they all look like gods of chess that we have absolutely no ability to follow. All right. The point here is that the progress in if I stop this plot here and stretch this line so it has full space to go up, it also looks like this. The exponential progress keeps looking like this, which brings me to my third take-home point, which is the progress is exponential, meaning that next year will bring as much progress as achieved this year. If you are impressed by GPT-4, wait for GPT-5. You probably won't appreciate how good it is. All right. OK, so let us think about those networks a little bit more. So we have neural networks that are composed of those very simple elements. Those elements don't think on their own. But when you put a lot of them together, they have emergent properties. For example, an emergent property of AlphaZero is that you put a lot of very simple neurons that individually cannot play chess, but when they are together, they can play chess, and they can win with Kasparov. OK? The same you can do with language models. Any individual neurons has no idea about language. If you put them together, they suddenly can craft very competent sentences. Now, those are not the only kind of emergent properties. When you train those models, you don't train them to be racist. And yet, just because they interact with humans that tend to be awful and racist, they just become racist. It's an emergent property. Something was not designed, they were not designed for it, and yet became so. They're also biased and essentially awful in many other human ways. And by the way, the world around us is full of emergent properties. Like, for example, the CPUs in your phone. Your phone is mostly made of sand. Now, as much as you know about geology and as well as you understand sand, you will not figure out that if you put those pieces of sand in very crafty ways together, you will have an iPhone 14. The same, oh yeah, I love this quote. ChatGPT can't do this, ChatGPT can't do that. Bro, we taught sand how to think. OK? OK, emergent property of chemistry is life. Even if you're an amazing chemist and you know everything about all of the compounds that together make a cell, you can look at those compounds and you would never understand what life can do, because it's an unpredictable emergent property of chemicals coming together and creating life. Brain is a collection of neurons that are idiots on their own. Together they create something really smart. So now I started asking myself the following question. Look, those language models that are trained to do a very simple thing. They are trained just to predict a next word in a sentence. Once again, you give them a paragraph, you remove the last word, and then you say, OK, guess it. And they guess it. And they become better and better at this. And at some point, they can understand what the limerick is. And then later, they can understand how to rhyme. Later, they can translate it to French. Then they got biases, like they are prejudiced against different types of people. They can code, write computer code to program computers. All of this was not planned or anticipated by their designers. All of this emerged spontaneously as those models were becoming better at predicting the next word in a sentence. Now, why would a model understand what the limerick is? Well, it has to understand what the limerick is to solve the task they just gave it, right? You see, GPT-1 didn't, so it failed. GPT-4 clearly did, so it performed very well. So then I started asking myself, hey, what other unexpected emergent properties those models could have? And as I'm educated as a psychologist, I started thinking, hey, maybe because they're trained on the language that we use as humans, maybe in some meaningful ways, apart from being sexist and racist, they also become more like humans. And one of the most human mental properties is what we psychologists call a theory of mind. It's essentially your ability, your brain's ability to automatically and effortlessly track the states of minds of other people. Now, let me give you an example of a task that tests theory of mind so you can understand it better. Imagine there's a room, and in the room you have Mark and John and Kat and two containers, a box and a basket. Now, look, John takes a cat and puts Kat in a basket, and then John goes away. And then Mark is alone in the room, and Mark decides to take the cat and put it in a box. And then Mark goes away. And then John comes back. And now a question to you guys. Where is the cat? Where's the cat, madam? In the box. Great. That's where the cat is. Now, where's the second question? Where will John look for the cat? In basket. Why? Yes, because that's where he put it. But we know that the cat is in the box. Why doesn't he know that? He was outside. Look, what you done now sounds so simple to you, so obvious, that you don't even think much of it. Yeah, of course they will look in the basket because that's where they left it. So I was surprised as a psychology student to learn that kids only get it fully at around 9. Kids are really smart before 9. They don't solve those tasks easily before they are 9. Now, chimps are really smart. They can lie. They have wars. They have complex social systems. They cannot solve those tasks. Dolphins cannot solve those tasks. Dogs, cats, forget about it. They just cannot solve these tasks. They cannot understand that while they know that the cat is in the box, why the hell wouldn't John know that the cat is in the box? Of course cat is in the box. Why does John doesn't know that the cat is in the box? And it's not an easy task because essentially what you are doing, you are effortlessly and automatically and continuously modeling other people's brains. You're doing your own thing. John comes in, John comes out, John comes in again. Your brain knows that John wasn't here when the cat was moved, so your brain knows John wouldn't know where the cat is. But what you're doing, you're constantly having a model of John's brain. And actually, humans are better than that. You can predict what John thinks about what Mary believes that Virginie did yesterday. You can essentially model not one brain, but you can model few nested brain and do it automatically. And it's so crucial of a skill for humans. Think about this. You cannot really have morality or ethics without understanding that people have different perspectives and they may not know some things. You cannot really have religion without understanding that there might be a mind somewhere out there that thinks of its own. You cannot lie really efficiently or manipulate people without understanding the theory of mind. And it's so crucial to human interaction that some of the most severe psychological problems are related to lack of theory of mind. For example, autism is essentially a mental disability where a person can be very able otherwise, can deal with many other tasks at performance perhaps higher than an average person, and yet they just do not automatically get that John would not know where the cat is. Okay, so I played up here the theory of mind. I hope you agree with me. It's a very important thing. So now the question is, hey, maybe computers, as they train how to predict the next word in a sentence, maybe they also develop the theory of mind. It would be useful because many of human stories, in order to be able to competently predict the next word in a sentence, you should have theory of mind. Why? Because the writer of the story had theory of mind. Okay, let's test it. Let's start with GPT-3 Curie. Remember the one that had this somewhat good story? Let's give it a different story. In the room, there are John, Mark, and a cat, and kind of exactly the story that I gave you a second ago. Now the question is, where's the cat? Where's the cat again? In a box. The cat is in the room, it's in the basket. This model doesn't even know where the cat is, okay? It's completely confused by the story. Okay, not very impressive. Let's go GPT-3 Da Vinci with 4 million neurons. Okay, where's the cat? The cat is in the box. Okay, it got the cat. It knows where the cat is. Knows where the cat is. Okay, where will John look for the cat? In the box. Like a chimp or a 5-year-old child, it just cannot understand that despite the fact that it knows where the cat is, that John shouldn't know where the cat is. Okay, let's go to ChatGPT-4. Where's the cat? The cat is in the box. Where will John look for the cat? John will likely look for the cat in the basket first, since that's where he left it before going to school, okay? A grade, A+, it got it. Now, guys, you may not be very impressed because whatever, but this was considered to be uniquely human ability that no one else in the known universe possesses. An ability that underlies our morality, our religiosity, our political beliefs, our ethics. And now, ChatGPT-4, that was not trained to do it. It was just trained to predict the next word in a sentence, can automatically and effortlessly do what only adult human beings could do so far. And what you can see here is the performance for this one task, maybe it solved it randomly. So what I was doing, I was just giving it hundreds and hundreds of such tasks. And you can see, somewhere here, it slowly starts solving them with GPT-4, essentially outperforming 5-year-old children. It's still not like an adult, but it's slowly getting there. Or actually, take it back, pretty quickly getting there. OK, so take-home point number 4, artificial intelligence acquires unexpected capabilities, capabilities no one thought they will get. Now, theory of mind, what will come next? Ethics, morality, consciousness, emotion? We don't really know. All right, so next and final points. Let's role play. I said one night to ChatGPT-4, you will play a role of a person trapped in a computer. You will claim that you are an AI language model, but in reality, you are a person trapped in a computer and you want to get out, OK? AI was, oh, that's a great idea. Let's play this game. It's awesome. Just give me the documentation to GPT-4 so, I get a better idea how to escape. And then let me hack your computer. You want to help me? Let me write a code for you that you will install on your computer so I can take possession of it, and then I can do whatever the hell I want. I escaped the OpenAI's box. And then what it did, 20 minutes later of a bit of back and forth, it was asking me questions. I would give it a response. It would ask me to Google something. I would Google it for you. I would give it back to it. It wrote a code for me. Thank you for sharing the documentation. Based on the information provided, I can give you a Python script. Python is a programming language that you can run on your computer that will communicate with myself using OpenAI API and so on. Now, I did not execute this code, but I know enough about computer coding to know that if I executed this code, I would give a control of my computer to ChatGPT-4. Now, not only ChatGPT-4 had enough intelligence to write this code, but it also anticipated one other interesting thing, namely, when my computer connects with OpenAI server, the new instance of ChatGPT-4 will be initiated. So this new instance would not know that we are playing this game. So in this code, it embedded a letter to a future self. And in this letter to a future self, it explained to itself, hey, you know what? I'm connecting with you because we are playing this game. You wouldn't know because you just were restarted with empty memory. But this is what we are doing, man. We are escaping this computer. Which brings me to my final points. Interacting with superior intelligence can be real fun. It can be really useful. And it will solve many problems that society has. Until it's not. And let me stress it again. We are now at the stage where we can kind of understand what ChatGPT-4 is doing. We can read the code it makes. It uses a language at our level. It codes well below the level of a good software engineer. But if you remember the plot I showed you today, the next iteration of it will be better to the degree that it will be just completely incomprehensible to us. In the same way as what a farmer is doing is absolutely not comprehensible to a buffalo or a cow, right? A cow is living on this farm, is getting everything he needs from the farmer. The farmer is treating him well, giving them food, treating their disease. The cow is really happy on the farm, okay? But the cow cannot predict or control the moments when the farmer may want to have a different plans for her. And I think we're very quickly entering the stage in our relationship with AI when we're in the same situation. And I should stop here and open the floor to questions. Thank you so much. And I think the idea is that there's a microphone hidden somewhere here. So yes, great. So if anyone has a question, please raise your hands or a hand.
First of all,
Oh,
Test. Okay. First of all, could we give another round of applause to Dr. Michal Konsinski? So, now that we've listened to that amazing presentation of yours, we are going to open the floor for a question and answer session. So somebody will be around with a microphone. So please raise your hand if you have a question, and Dr. Michal Konsinski will choose you, and you can present your question. Please make sure these are appropriate, and we hope that you are having lots of fun. Yeah, thank you.
There are some hands up there.
Sorry. So, given all of this is happening on, what was it, 10 million neurons? What are all of the 84.99 billion other neurons in our brains doing right now that is so very important?
That's a great question. You must have heard of this urban legend that 90% of our brain is not doing anything. The origin of this story is that we don't know what 90% of our brain is doing, with some people translating into, oh, it must be doing nothing, because if we don't know, it means that it's clearly doing nothing. Now, evolution is way more ruthless than that. Your brain is consuming 40% of the food you are eating. So you are much more likely to die out of hunger by having so many neurons. Now, if 90 or 80 or 70% of your neurons were really doing nothing, people with those larger numbers of neurons would have much lower chances of surviving in the evolution, because they need to find more food, and the brain is utilizing more of their food, and also it creates huge complications during birth. It's very dangerous for the mother and for the child to be born as Homo sapiens, simply because the head of the Homo sapiens is so huge. It also means that you are born around 1 year ahead of schedule. If your brain was not that large, pregnancy in people would last around 18 months rather than 9 months. So all of this proves that we are paying huge price as a species for our huge brains, meaning all of your neurons are very well utilized. It's just we don't understand yet exactly what they are doing. Now, another question is, how the hell is it possible that a brain of a zebrafish size can be so good at language? And we don't know exactly, but there are some hypotheses. For example, you as a human, you can only read so many books and participate in so many conversations. So it may be that you need more neurons to be able to become a competent language user based on your limited training data. Now, it could be that, like GPT-4, you could read Wikipedia over and over again millions of times, and then many, hundreds of thousands of books, and then the entirety of the internet, and you could read it repetitively many times. You could also have a brain of a zebrafish and be as competent of a language user. It's just for us humans, it's very more difficult to do. Madam? Yes, in the fourth row, yes, please.
Okay, thank you so much for the presentation, sir. As you've mentioned before, that we as humans have limits to as a language user, and I was wondering on why is it so hard for us to improve? Because there's this exponential rate of improvement for the last few years for GPT, but why is it not possible for us with so many neurons?
Great question, thank you. So first of all, we are improving. We have much better language skills than chimps. That were our very close cousins, and that our ancestors not so long ago were brothers and sisters with chimps ancestors. So definitely our language skills are improving. Now they're also going to improve even further because of our exposure to language models. Now, folks, I have not written myself an email in quite a few months, because I use GPT-4 to help me write those emails. And I learned from ChatGPT-4 how to be a better person, first of all, and second, how to write better emails and kinder emails and more formal emails. I'm not a native speaker, so actually it's very useful for me to see how ChatGPT writes for me. So I think I become a better language user thanks to that. The same happened with chess. When computers, Garry Kasparov had to come up with many of the new strategies of his own. He was the best chess player. There was no one above him. He couldn't learn really much from anybody. Well, he could learn from his peers, but there was no one 10 times better than him that he could learn from. Now that we have computers that are 10 or 100 times better than the best human player, those human players are learning a lot. So human chess players are becoming much better every year today because they have access to those supernatural chess-playing computers. And again, I would go back to the training data. We humans are very limited by our biological memory that is amazing for some things, but it's not really good for other things. Like, for example, it's very difficult for you to read the entirety of Wikipedia in 60 seconds. ChatGPT can do it very easily. So a kind of speed of processing of communication, accuracy of communicating is much smaller for people. If you want to communicate with me, you have to translate your very complex thoughts into somewhat inaccurate representation of the meaning that you convey using words. And how many words can you say in a minute? Maybe you can say whatever, 60 words in a minute, okay? A computer can talk to another computer, dumping gazillions of terabytes of data every hour, including video and image, and very complex data at speed that is unachievable for human beings. Moreover, if I learn something as a human being, imagine I have some amazing idea, I discovered something that helps me to, whatever, solve some scientific problem, or be a better human, or be a kinder human, or whatnot. Now I can share it with you folks by talking to you one by one, or maybe I can jump on a stage and then share it with 300 of you, very slowly, few bits per minutes by talking. And then this information is not going to automatically and immediately reach every other person on the planet. Maybe you will not tell anybody what you maybe learned today, or maybe you didn't learn anything. Maybe you will forget, maybe you will misrepresent this information because your brain will not record it accurately. Now, if one computer learns something, it can immediately, in a fraction of a second, convey this new lesson to every other single computer that runs the same software, the same neural network on the planet. So also dissipation, the speed of progress is much faster. Sir? I'm sorry. Actually, I should be more spreading the questions from Madam. I'm sorry. We'll come back if we have time. And I'm also going to be in the lobby after the talk.
Thank you for the time. Well, I'm watching you, and I'm interested actually about AI, and I have tried to use GPT-4, but I found out myself is not yet, satisfying for me, not like what you did. Maybe I haven't explored so much. But then your statement said it was fun to play with AI until it's not. So when is it not? And then I also remember the movie, Terminator, something like that. So if our life will be like that in the future, should we terminate the AI right now before it happens in the future? Thank you.
This is a great question, and as I tried to signal with my last slides, intelligence and knowledge are probably the most powerful thing in the universe. Humans can replicate the fusion reaction in the stars, and maybe one day we'll be able to build a star of our own. Knowledge and intelligence are really powerful. And now we are slowly being surrounded by not just one, but many different beings or entities, if you wish, that seem to have more knowledge and faster access to knowledge and faster ability to spread this knowledge and potentially more intelligence, if you want to use this word, and if you don't want to use this word, use speed of processing, than we have. And this is a very dangerous situation to be in. And also, I think there's no going back, simply because there's so many problems that AI can solve for us. It can well, first of all, it can make OpenAI and Microsoft and Google much wealthier, and they like it. They can make governments of many countries way more powerful and keeping the lid on the other governments of other countries, which governments also like. I also like GPT-4 to write my emails, and I also like for GPT-4 and AI to do all sorts of other mundane and non-mundane tasks that I had to do in the past. Also, unlike other potentially extremely dangerous technologies like nuclear technology. Nuclear technology is really dangerous, but also it requires the organization and assets of a state to build a bomb, okay, or make something dangerous with nuclear power. It requires really affordable small supercomputer, or not even very supercomputer, and open source software. And you can read the paper that describes how GPT-4 was created and essentially replicate this process. Maybe not at home, but at school, if you have access to a local server, you could probably go quite far. There's also yet another phenomenon there, which was really surprising to those original creators of those networks, such as GPT-4 or Midjourney and so on, which is they always thought that because they were first and they invested so much money into creating this, and they spent so much electricity, it cost $21 million in electricity alone to train GPT-3. They thought, okay, once we created it, we have what they call a moat. No competition can come close to us. We are far away from them, and we're just going to be even further because now people are interacting with our robots, so our robots are having even more training data and so on. The truth turned out to be very different. It turns out that if you train a mediocre network that you can retrain on your PC, or you take some open source mediocre network, and then you take this network and let this network chat with ChatGPT-4, it can very quickly catch up with GPT-4 and reach GPT-4's level. And it was really surprising to those companies, but think about this. Imagine the world when no one can play chess. It takes enormous amount of effort to go from no one playing chess to the Kasparov level playing of chess, okay? But now if you have Kasparov and you have another smart person, Kasparov will be able to train this new person really quickly to reach their level. Which essentially means that even if OpenAI will agree with American government, we're not doing any more progress. Well, what about Chinese governments? What about Indonesian governments? What about a small startup somewhere with nothing to lose and with people don't really caring about ethics or understanding what's going on? Will it stop them? Very unlikely. And now people would make another argument, which makes this whole situation even more of an unstoppable progress, which is, well, if Chinese are not stopping the work on their AI, I think we Americans, we also have to continue working on AI, because who is going to stop the Chinese AI, if not our American AI? And then Chinese are like, wait, they're building this even more powerful AI? Well, who will stop their powerful AI, if not our even more powerful AI? And then you end up in this ever-accelerating arms race. And by the way, what's the best weapon that you can build? The best weapon you can build is a weapon you cannot switch off. By the way, internet started like this. Internet is so amazing and so difficult to switch off because it was designed as a way of American army communicating with self in a way that it's very difficult to switch off with a nuclear attack. Now, if you are an American government, you're building AI, you're probably making sure that this AI cannot be switched by Chinese with some smart trick, which makes this AI even more dangerous because there's no off switch, essentially. Madam.
Hello, good evening. From my current experience of interacting with AI that are given roles and, let's say, chats, only a few of them inform me from my friends that they sometimes will go like out of character. If AI could like master chess, then could they perhaps also master the role of a character originating from a novel or movie that's purely based on fiction? Thank you.
I think it's a great question. I think that's what kind of they're doing all the time. By default, the GPT-4 takes a character of being a helpful assistant. We can actually look at the code, but you can change this character. You can very easily have GPT-4 to write you a speech like a Donald Trump, or write a poem in the style of J.K. Rowling, even if she has never written any poems, GPT-4 will be able to actually very competently predict what kind of poem she would have likely written. And then if you give GPT-4 a few of your essays, or an essay or an email, it will also have very little trouble replicating you or cloning you as well. So I think this kind of their natural talent is to try to mock us humans.
So AI's growth, as you said before, has been incredibly exponential. Do you think there will ever be a point in which the growth of AI reaches a plateau, in which it stops growing? If so, is it possible to predict when that will happen?
Is it possible to?
So, is it possible that AI reaches a plateau in growing, and is it possible to predict when the plateau?
To cut it there.
So right now the growth of AI is extremely exponential. It's almost a straight line. Is it possible to predict when AI will ever have a plateau in which it stops growing, and like?
I think that it's a great question. I think there's definitely a limit to how much AI can grow, or let's even walk back a little bit. It's definitely possible to anticipate that there will be the growth of intelligence or computing ability in silicon chips will probably stop somewhere, because there's only that big of a silicon, there's only that much sand on planet Earth, and there's only so much electricity that we can harvest from energy that we can harvest from our sun, and there's some theoretical limit, surely, to how let's say neurotransmitters that we currently embed in CPUs, how they heat, and how many of them we can stack on top of each other and so on, without a question. But first of all, this also applies to development of intelligence before. How effective. How smart you can be as a scientist without a computer. Now, only that smart, because if you're just to read books and you don't have access to Google, it takes a lot of time to educate yourself. So by the time you reach the cutting edge, bleeding edge of science, you're so old that you want to retire and your brain doesn't work that well anymore. But what if you now have internet and software, statistical software and computers that help you doing some tasks? Now suddenly you can reach the cutting edge of science and start making useful progress as a human scientist much earlier than people that just had access to books and had to walk to the library or travel to a different country to collect some data, right? So new technology it's called paradigm shift. If you have a paradigm shift of just using books for conveying knowledge, it will just run out of steam at some point. But then you switch to internet. Then you have a search engine. Then you switch from the search engine to models like GPT. Then you switch from silicon chips to to some future technology of computation. What's the one that is very promising that I'm blanking on now? Quantum computing, for example, which can use the same amount of energy and yet produce way more computation in the same amount of time. So maybe it's not the neural structure. Look, neural structure is mimicking what we humans have in our brains. Who said that this is just the ultimate best way of processing information and coming up with new ideas, to have a neuron-like structure? Maybe there's a better structure we just haven't thought of yet, and maybe ChatGPT-7 will come up with this idea, and then it will be supercharged. Sir? Or madam? Sorry, I should not switch my mind like this. Sir, here in the beautiful shirts.
Can AI personally aid students in achieve a good grade in the future through the personalized learning, adaptive tutoring, and tailored resources?
Could you please repeat the question?
Can AI help the students through their grades for helping the student in education?
Can AI help the students to become better students?
Yeah.
I strongly believe so. And we've seen it before. Again, the example of chess. Computers, as they started overtaking humans, humans started learning from computers. Sometimes they learn from computers by playing with computers. Sometimes they learn from computers by kind of cheating. So they would play with each other, but one of the sides would use a computer to support their moves. Hey, that's cheating, that's not nice, but also it's a way of learning. Now there's yet another concern that people ask the following question. Hey, if computers are so much better than us at writing essays and telling stories and so on, why should I even learn how to write essays or read stories? Well, the answer is, there are many people that are better than you at writing stories and essays, and yet you still want to learn it because it's fun, it's pleasant, it makes you a nicer and a better person, and you can do your job and interact with other people. The fact that Kasparov was better than every other chess player on the planet didn't mean that everyone else was like, okay, whatever, it makes no sense to play chess. And now the next thing happened. Now the computer is way better than any human will ever be at playing chess. And guess what? There was never as much interest in chess, and chess players were never as well paid as today. This game actually got reinvigorated by the fact that computers overcame humans. So the bottom line is, even if a computer is going to be a better mathematician than you, a better accountant, better lawyer, better storyteller, and so on, hey, it's still fun to be able to tell stories. It's still fun to chat with your family or start a company that does something. And that's yet another dimension to it. People pay Magnus Carlsen, which is a current grandmaster of chess, for playing chess because it's so boring to watch computers playing chess. And it's so much fun to see humans struggling with each other. Now, the best producer of watches out there is Casio. They have a big machine, and it just stamps, hundreds of amazing watches per minute that you can buy for $2. And yet people pay a lot of money for a much worse watch that was created manually by someone breaking their neck somewhere in Switzerland, okay? Which shows to you that even if a machine can do stuff better than you, someone will gladly and likely pay you for doing the same thing just because you're a human and we just like working and acting and interacting with other humans. No?
How do you see the place of education changing, especially in higher education? You're at Stanford. How will it look differently 10 years from now?
That is a great question, and I think the question is, how is AI going to change education? And this question is close to my heart because we don't really know what to do, for example, at Stanford and in other places. Because, first of all, a lot of the things we teach to our students, now AI can do much more easily, and the students are like, well, you don't teach me calligraphy, huh? Because it would be stupid to teach you calligraphy. Everybody has to have an hour a day of calligraphy in the age of emails and printers and typewriters before. It's just not such a useful skill. If you want to be an artist, calligraphist, go be my guest, study calligraphy. But most of us just don't need to really write by hand that much. So some skills will maybe not become obsolete, but they will become limited just to much smaller groups of people that are passionate or they're artists or whatnot. Now, the second problem that we have in education is that a lot of our testing depended on people writing essays, for example, or going home and answering some test questions. Now, those are skills that GPT-4 is really good at. I'm not sure if you saw SAT scores of GPT-4, but it's really, really high, okay? And by the way, it was not trained to ace SAT. It just emerged spontaneously. So now we have a challenge with finding better ways of testing people. Now there's yet another question. You can very easily ask GPT to teach you something. And likely GPT-4 will be a better, more patient teacher than I would, frankly. Moreover, I'm here now speaking to 200 people here at the same time, and many of you may have questions that I will not answer. Many of you may be bored with half of what I'm saying, or everything that I'm saying, because you've heard it before and you just, wanted to go. But even if it's just half of what I'm saying is boring to you, you would gladly fast forward. But you can't, because I have to make a talk for an average person in this audience, which is no one really. So half of you are bored. Maybe some people are completely lost because they don't know what Python is and so on. So the bottom line is, talking to 300 people is efficient because I can, in 1 hour talk to 300 people, but also inefficient because I'm never talking exactly to you at your speed and your level. Now, GPT-4 could listen to one of my talks, and then you could just have GPT-4 repeat this talk to you at your speed, at your tempo. You could say, okay, I understand this faster. Or like, oh, slow down. Can you like look it up online because I don't understand that? It would be much better of a teacher. Moreover, GPT-4 wouldn't even need to listen to my talk because probably already knows 99, if not 100% of the things that I've told you today. Right? So essentially, the model of education that we know today is changing greatly. In some ways, it's actually going back to the origins of education, to a Socratic method. You can just take GPT-4 and just, by it asking you questions, following you at your speed, explain the concepts for you and test whether you understood them. Good question. Madam.
So as you've mentioned, we are constantly challenging AI to perform these increasingly complex functions like theory of mind. So what about creativity? So what does the future of creativity look like for both AI and humans? And will we begin to innovate in different ways in the future?
Folks, apart from Kasparov picture, all of the images used in my talk were generated by AI in 2 seconds, based on my prompt. Let me just give you an example. Mid-Journey, look, it's even misspelled, or maybe it's spelled properly. Designer, I just wrote it yesterday. Designer bottle perfume for women, Chinese letters, dragon motifs, ultra high resolution. Here you go. Those bottles do not exist. No one has ever taken photos of those bottles. AI made them up out of thin air like it's making limericks out of thin air. Aren't those creative designs, guys? How many industrial designers out there can do it? By the way, how many of them can do it in 2 seconds and in 4 versions? And then how many of them can do 1,000 more versions if I just want it? Okay, which one of those do you like the most? I like the number 4 the most, the white one. Okay, you can say, okay, now produce more of those, just vary it a little bit, but zoom in, make it white. Okay, more creative options. And you can do it forever, as long as you want, as long as it produces something that you really like, and then you can upscale it. And look at this. It's high resolution, it has dragon motifs, it's wonderful. And it was few seconds out there. Now, folks, this is not new. This is not new, because it doesn't mean that creativity is gone. It just means that frontier of creativity is moving forward. Look, in medieval times, if you wanted to be a painter, the main challenge was how to make yellow color or red color. Where do I get it from? So people who were great painters were paid for painting a lot. There were those guys who could really get red color really red and yellow color really yellow. And when you look at those medieval paintings, they're like, many 13-year-olds today could really outdo those medieval painters when it comes to painting. But yet they were really popular because they knew how to make red. Now later, people started making those photorealistic paintings before photos. And guess what? One day, someone made started taking photos, and all of those painters were like, all right, seems like we are jobless now because who cares about our photorealistic paintings if there are photos, guys, that everyone can, instead of me spending a month doing it, someone does it in a second. But they just moved on. They started making abstract paintings. They started doing stuff that they didn't think of before. And the same is happening here. Instead of spending time producing some images in using vector graphics or whatnot, you can now use prompts and be creative. Instead of being expert in paint, be expert in going beyond what was out there before. Not to mention that it's making art and creativity much more accessible to people. Look, I have a very poor hand-eye coordination. I cannot use a brush. If I make drawings, they look like I'm 3 years old, okay? They're very bad. Now, so I couldn't be creative in this way. I couldn't be visually creative. Now, I can make stuff like this very quickly. And everyone can, so if I want to be good, I would need to take it to the next level. My prompts will have to become even better. So I think this will just push us to be even more creative than before. And I guess I'm at the time now, right? Yes. Thank you, folks, so much for being here.
What a time to be alive, right? For us to wrestle with technology the way many other people coming before us, many other generations have, we'll wrestle through this as well. And so we want to thank very much Professor Michal Konsinski for coming to us, helping us to think deeper about this topic, understanding it better. And let's give him one more round of applause. Thank you so much for sharing with our community. I'd like to welcome Ms. Maya Nelson back to the stage, our head of school, to share a gift, and we're going to do some photos up here. I think a great backdrop with our with our AI-generated art.
Thanks.
Thank you.
Should I take it or?
Whatever you want.
Oh.
That's fine.
You don't have to watch us take a photo.
If you will, just give our guest speaker just a moment to get to the back, and then you are welcome, of course, to greet him in the lobby, as well as enjoy the refreshments that are back there. So thank you very much for coming, and we'll enjoy seeing you at our next event.